Okay, so if we're going from mass to moles, we're going to have to calculate the molar mass. So 4.27 grams of H2O2. Put that over 1. Molar mass takes each of these atoms and adds the atomic mass of those. So I've got 2 hydrogens and 2 oxygens. 1.00794. 0.00794. 15.9995. 15.9995.
Hey, Mr. Kelly. Every day I come into class and look at these signs and I read it. You know what I'm saying?
What sign is that?
Today, failure is not an option, it's a requirement. What does that mean?
Okay, if you'll give me a minute, I will explain that to you. I'm actually glad you asked me that question.
Yeah, like it's required. I'm not bad. And what?
Okay, I need everybody to pay attention here and talk about other things another time. I need everybody to pay attention here and talk about other things another time.
We're talking about this instead of the oxygen is 994.
Oh, did I put it in here wrong?
Yeah.
You know what? I put it in my calculator right. Put it down here wrong. You're right, it is. I don't know why I put 5 on there, but see, it's 9994 on my calculator. Okay, so you got a couple empty slots over here. This is grams of H2O2. And I need to round that off to 34.0147 grams of H2O2 equals 1 mole of H2O2. So now I have an equality statement, and from the equality statement you can always write a conversion unit. The way you write the conversion unit is you have to have a fraction, and you look at the equality statement and pick the side of the equality statement that matches the units and species that are remaining in your problem. So this front side, this left side of the equality statement has grams of H2O2, and so does this step up here have grams of H2O2. So this side of the equality statement needs to be on the bottom of your conversion fraction, your conversion unit. 34.0147 grams of H2O2. Now, this is the part that most students mess up on right now. They won't bother to do all the details. They won't finish the equality statement, and they won't write the conversion unit properly. And it's really simple. But you know what? Students try to take shortcuts, and a shortcut's not a shortcut when it gets you lost. So don't take shortcuts. Watch the details. Okay? They're really important. Alright, so now we're ready to do the math. We need to cancel units.
Mine came out like 36.
This. Then you've done something wrong. You have these values.
I put them in my calculator.
You didn't write them down on paper?
I wrote them down. When I wrote them down, I didn't do them.
Did you do all this? Did you write them vertically?
I told you my calculator around right.
Well, that's not a rounding error. That's something else. It's 36. Okay, you need to fix your calculator or come in and let me do it for you if I can. I'll try. And you need to have it written down in detail so I can tell what's going on.
I did. It's right.
All right, so we want 4.27. Not 42.7, 4.27 divided by, I got a number on the top, one on the bottom, so this is a division problem, divided by 34.0147. Okay? And I got 0.125539603. We need to round off. And I've got 3 digits here, and 1, 2, 3, 4, 5, 6 there. So I only want the number with the measured or calculated number with the least digits. These are counted numbers. These ones are counted numbers. We don't worry about those. We only worry about the measured number here and the calculated number here. And this, of those two, this number has the least digits. So that's 3 digits. Leading zeros are not significant. So that's our first significant digit right there, the number 1. This is the second. This is the third. Everything else gets rounded off. I need to make sure I have the units of measurement and the species. And now I'm ready to round this number off to 0.126. This 5 here causes that 5 to round up 1 digit. Okay? Moles of H2O2. Okay? All right. Did anybody have any problems about that? They want me to answer questions about it? Anybody not get the correct answer in some fashion you want to discuss? All right, then. I'm assuming you know how to do this stuff. All right. I want you to do it in just a second. As soon as I'm going to get started with the problem here, and then I'm going to have you set up while we're getting ready to go over it. Okay? All right. So we've learned then to convert from moles to particles. And we've learned to convert from particles to moles. Particles can be atoms. They can be molecules. They can be formula units. They can be monoatomic and polyatomic ions. Okay? And we've done that kind of math. We used the Avogadro's number for that. Which is 6.02 times 10 to the 23rd power. And we said this many particles of any substance is equal to 1 mole of that substance. Okay? And that was the equality statement we needed to make these conversions work. Okay? We've looked at converting from moles to mass of a substance, or from mass to moles of a substance. And the way we got the equality statement for that was we added all the atomic masses of all the atoms in the formula of that substance together, wrote the answer in units of grams, and put the species on it, and then set that equal to 1 mole of that substance. And that's called the molar mass of the substance. Okay, and we get an equality statement from that, where the grams, which are equal to all the atomic masses all added up, equals 1 mole for that species. Okay. In your mole project, we haven't done any math with that yet, but in your mole project, you should have had written down in your presentation how to get from moles to volume of a gas. Yes. Yep. I said yes. Sure. Okay. So we went from moles to volume of a gas. Now we haven't done the math in this unit on that. We'll do that in the next unit. You should have learned, you should have taught yourself in that mole project how to do that. And the relationship for that was that 22.4 liters of a gas equals 1 mole of that gas. Whatever that gas is, it has to be the same gas. You can't change from one species to another. That has to be the same. Okay? But this only works under a very specific set of conditions. And that conditions, we shorten that to call it STP, that's standard temperature and pressure. which is 0 degrees centigrade and 1 atmosphere pressure. Okay, we're going to do one more kind of conversion now in this unit. One more kind of conversion, and this is converting from moles to moles. From moles to moles. So this conversion is moles of one substance to moles of another substance. Okay? To make this work, you must have a balanced chemical equation. And you use the coefficients to write the mole ratio. We're going to use the coefficients to write the mole ratio for this kind of conversion.